A spherical black body with a radius of 12 cm radiates 450 watt power at 500 Kelvin. If the radius were halved and the temperature doubled, the power radiated in watt would be. So this question is directly based on the formula which is called as a Stefan-Boltzmann law, and using that formula we can easily find out what will be the power radiated, the watt when the radius is halved and temperature doubled. So let us start with the formula itself. Stefan-Boltzmann law and which gives a equation that power radiated by the black body if represented as P, then this P will be equal to sigma A T raised to power 4, where sigma is Stefan-Boltzmann constant. Sigma is the Stefan-Boltzmann constant. A is the surface area, and which is equal to our 4 pi r square in case of sphere, is our surface area, and T is the temperature in Kelvin. So before the increase of temperature as well as you can say radius, the power, let's call that power as initial power. So we can say initial power, or let us solve this equation first. From here we can write that the radiated power P will be equal to sigma pi r square and T raised to power 4. So we can say our power radiated is directly proportional to square of the radius and fourth power of the temperature. So we are going to use this equation. Let us call this equation 1 for initial as well as final. Here initial means before the increase of radius and temperature, and the final means when the temperature is doubled and radius is halved. So we say initial power we call that as Pi is directly proportional to initial radius Ri square and temperature initial, that is raised to power 4. And similarly we can write final power, let us call that Pf. It will be directly proportional to radius final whole square and temperature final raised to power 4. And let us find out their ratio. So we can write that Pf upon Pi will be equal to radius final square, temperature final whole raised to power 4, and we have initial radius square and temperature initial raised to power 4, which can be written as radius final upon radius initial whole raised to power square and final temperature divided by initial temperature whole raised to power 4. And it is said that the radius is halved, so we substitute the values. This gives us half, and we have this as whole square, and temperature is doubled, so this becomes 2 upon 1 raised to power 4. So this is equal to 4. Therefore, we can say final power will be equal to 4 multiplied by initial power, and initial power is given as 440. So this becomes 4 multiplied by, sorry, it is 450, and which comes 1800 watt. So it means when the radius is halved and temperature is doubled, the power radiated by the body, so we can say the power radiated by the body when the radius is halved and temperature is doubled is equal to 1800 watt. So the options that are given to us, option number D will be the correct option. So you can say option D. Option D is correct. So this question was directly based on the Boltzmann formula, Stefan Boltzmann formula rather. So this completes the question. Thank you.